Okay. I think it's working. I'm testing new cameras again. So, hello guys, welcome. It's been a while since I did the live stream. I figured since I have to go over some 3D printer maintenance after my silent 3D printing project, then I thought it's gonna be a good idea just to do it live. You can join me, take a closer look what I've done with the printer if you haven't seen the silent 3D printing bit. And I already have an article about maintenance for your 3D printer that you should definitely check out at some point. I'm definitely going to be dropping into a chat at some point. But everything seems to be fine with my printer, although I've noticed some ringing, so I have a little bit of play on one of the axes. I want to fix that, and I need to figure out the cables as well, because right now the cabling and managing the cables on that thing is rubbish. So let's jump to my 3D printer setup. Ta-da! Now, this is the thing, right? This printer is already running. This is like you can see that the printer is enabled, and absolutely in no way it gets in the way of live streaming, even when it's printing. So I can just go and home it for your pleasure, so you'll see it moving. And yeah, the microphone is pointed at me and the printer because it's there. And yeah, that's how loud it is. Hello Andrea, how are you doing? Do you have TL's motor diodes? I don't believe so. I'm running this, this is running on a custom board as well, so I'm not running the Creality board, using SKR Mini E3 1.2, so one of the older boards. But absolutely fine for this printer, I have no problem with it. With the ringing, majority of the ringing problems, it's related to mechanical issues. It's actually not a problem with the board itself. So unless your steppers all over the place, unless you've got some play, I don't believe it's a board issue. Where is my? I can show. I mean, like, there's a tiny bit of it. I'm not being excessive. Like on my other printer, I was running a couple of prints. Can I get this to focus? You just flip out the screen so I can see what I'm doing. So this is on my water-cooled printer, which I'm shooting the video today. You can see some lines in here, but that's fine. I actually don't mind this. But this one, what have I printed with this one? I had some retraction tests done. I have occasional, it's a white part, I don't know if you're gonna see this. I have there's a line in here, like something went wrong and there is this line. It shouldn't happen really, it's on both parts of the print, so it's shifted layer a little bit. And since it's on almost every edge, it wasn't happy about something. So basically the idea is that I'm going to check each axis, check the wheels, clean them. I might have a little bit of dirt, and that causes the extruder to bounce up and down. Hello, can I increase the chat? Let me just increase the chat view as well, because it's super tiny and I'll have to lean to, because it's a Chrome window. I should be able to. No? Oh, bollocks, look at that. I can't. Do I have any? Let me see if I can increase the chat font somehow, because it's quite far away. And hello Janice, and hello James. You're right. Is your bed sticking right now? And hello Quad. Hope you are doing well. Just looking for the options to increase the font. Time stop, participants, moderators. Just give me a control plus minus. No? Bloody hell. Where's the fun? Okay, maybe in Streamlabs I have some more options. Let's see. Participants, those are same options. Those are dashboard, refresh chats. No, I don't. I'll be squinting. That's what's gonna. Oh, I know what's gonna happen. I'm just gonna go to display settings and set the display scaling to like 175. and I should be able to see everything. Oh, now we're talking. Thank you. All right, excellent. Although I don't see my live stream as well right now. Okay, now I can see it. Right, so there's a couple of things. First of all, you will see a couple of custom things. First, we're going to start with disconnecting power. And to disconnect power, all I have to do is just go to my, I could unplug it, but come on, where's the fun in that? And just go to my app, go to my ender, press the button, and the printer is down right now. It's disconnected. So I can do it remotely. Okay, so let's unplug it so I don't shock myself. Ah, forgot there's a screen connector, that's why the light. So I'm using one of those screen thingies, you know, for light, for the light bar for screen, which is excellent for 3D printer. So I use that, and it's connected to this small attachment in here, which is basically I broken down an USB charge and connected it in parallel to in my power supply. So I essentially, what I did, I have a USB connector in here, and I can plug things like Octoprint. This is 3 amps, like Octoprint, extra lights, etc, etc. I do that mode for all my printers. So let's disconnect this. I also have a module fan. I'm designing another version. Can I zoom in a little bit? Maybe you'll see that a little bit better. So I can change different fans. At some point I'll have to go to the door because I'm expecting delivery for some tools, and a bigger blower because I need to swap this for a bigger and quieter blower. And yeah, and I have custom connectors in here, which means if I'm changing something, all I have to do is just unplug these, and I can basically remove entire extruder head without messing with cables, which is super comfortable. So that's what we're gonna do. First of all, if you want to maintain your 3D printer and see what are the common problems are, first mechanical things or dirt. So there's a couple of things you should look at. You can check the tracks and run with the finger across bottom and the top where the wheels are spinning, and just feel it for any imperfections. Now I can feel a little bit of dirt in there, so I'm just going to keep rubbing it until there is no dirt in it. When you think about it, when you have like a piece of dirt and it just stuck in there, it will make your extruder bounce up and down, and that will affect the print. When you think about it, when you are leveling your bed is leveled to like 0.2 mil, and it's very easy for this dirt to be even more than that. So now I'm kind of happy. We're gonna be investigating wheels in a second. But the same applies to all axes that using wheels. So I'm just going to zoom out a little bit, and then I'm just going to run my fingers in here on both sides, and then I'm gonna raise the z-axis. That seems alright. So raise the z-axis a little bit. And let's check where the tracks are usually. I can feel a little bit of biting in here. There was something stuck on the rails, so that can cause your wheels to bump, and you don't want any of that bumping, because you know it's a very simple check and something I would recommend you to do. I've got something in here. I needed to use my nail to get rid of it. Okay, so. And the last, it's the bed in here. So it's the top rail. Again, I can feel this bit. It's a little bit sticky. To be honest, it's been ages since I did this, so you can see my fingers kind of covered with the. It's not a dust. It's kind of leftovers from the wheels. So when the wheels are rolling, they are consumable. It will take a good while to get rid of them, or to run them down, but they are consumable on printers. Okay, I'm happy with this. Now the second tip is, when you checking for play on the 3D printer, don't do it with the belt on. I know you might be tempted to do it with the belt on, but don't, because you are being kind of lied to. The belt can make it feel like everything is all and nice and dandy, but quickly undo the belts, and then you'll be able to tell if there is any play. So there is this tiny little bit. That's hard. I'll take the ratchet instead. So there's this belt tensioner in here, which I'm going to loosen up, and then I'm going to remove the belt, because this is how you can tell if you have any problems. So loosen this up, remove the belt at the bottom, you just slide it out on this like this, and now you can test the rolling resistance of that. Check for the movement across all axes, so check whether it's moving like this, like that. And start with the cage first as well. After the cage, we're gonna examine the extruder, whether the extruder is actually mounted correctly. Now when you're moving your, when you're gliding across, you also should kind of just drag your nail across the wheels. You'll pick up any imperfections. I have a little bit of something stuck in here. It's a small bump, like I said, it's probably not going to affect that small one, but since I'm here and I'm checking for all the stuff, I might just as well just clean it. Okay, I'm happy with this one. Let's see, this one has a little bit of stuff stuck to it. Like I said, over time it's natural for the things to kind of be in here. And the bottom one? Yeah, bottom feels alright. Now I'm going to take my extruder apart, just check on it as well. It's been a while since I've done that. Probably my screwdriver, my magic screwdriver. So let's, oh, it's going to be difficult to reach out. I should have prepped all the tools. I'm just get these in hand. Let's have a look at the charts. Of course, we're gonna re-level everything later. This is Ender 3, yes, this is just Ender 3, but it's probably surpassed the Ender Pro capabilities in terms of upgrades. Yeah, you can do the wire brush, that would work perfectly. In fact, you know what? I actually got the wire brushes. I purchased them, what, yesterday or the day before yesterday. Where did I leave them? I had 4 wire brushes. Is it in the drawer? Huh. Ah, here. See? Ta-da! You can use one of these and then just, that's gonna be even better than your nails. You can get rid of all that stuff, especially from the wheels. And so it's the same. So the same principle. So we're gonna be taking, we're gonna take the shroud out. It's not particularly needed, but if you suspect any problems with print quality, ringing and stuff like that, then it's good to check on it and see if there is anything that you should be worried about. I have a lot of different things in here, so I need to get rid of it. Ah! Come on, seriously. I don't have a proper angle on that, unfortunately. That should be better. I have a BL Touch installed on this extruder. There is an all metal Hotend as well, and a Noctua fan and a custom fan on it. Come on, you can do it. Alright, that's only 2 screws. Keep them handy. As you can see, thanks to the connectors, I can just remove this part straight away. And it's very handy. Same for goes. Extruder isn't attached anymore. You can see all it is just a tube. Now, I made a small mistake in here. I should have removed the filament while it was hot. So there's a couple of things that we can do to do it. Like we can pull it out and cut it in here, and then you can keep it inside. Or you can just work your way around it. For now, I'm just gonna work my way around it. Otherwise, I would have to just heat up the extruder to remove the plastic and check on it. Now, what I'm looking for is a play in a Bowden tube. There's none. It's fine. Once to check for it, you have to remove that plastic nipple. Can I zoom in for you guys? See, I've got that fancy camera so you can see it. So this plastic nipple, basically, if you're new to everything, it prevents Bowden tube from getting out. That teeth inside is coupling, and those teeth are kind of biting into the plastic tube when you put that thing, that small washer. So see the dipply, then put that, and it's not going to go anywhere. Now I have a little bit of leaking on the outside, and honestly I was lazy last time and I didn't clear it, but I'm gonna give you a really handy tip for how to clean extruder bits. So let's undo the extruder. Alright, you can see it's a little bit of leak. It's old one because it's black as well, so it's been burnt pretty well, and yeah. I could use a new block, to be honest. I had an accident where I blobbed it properly, and now it doesn't look as pretty. But when you're screwing this in, let's unscrew it out. Actually, I'm waiting for proper tools, which I could arrive, because the included tools for the nozzles are horrible. So this is for my brake, and I need one for my nozzle. Now these things are horrible because they bend straight away. You can't read. What controller? This is I'm using the SKR old motherboard. This is what is it called? Mini E3 version 1.2. Firmware I've compiled myself, so that's slightly more difficult to explain. So when you're removing this, if you have a lot of things around, then you probably want to heat it up. If you don't, should be alright. But when you're putting it back together, you should screw that in, heat up your heating block, and redo it again, because once you heat it up, kind of you're gonna get a little bit of more play. Okay. Let's try to undo it. Too wide, I need to kind of squeeze it. This is a rubbish tool. Like I said, this is one of those included in a thing, so. This is definitely I have a hardened nozzle. Again, this is opening because the metal isn't hard enough for these. I actually have a set of small wrenches coming up. They should arrive anytime. They said between 3 and 5 today, so I was kind of hoping that they're gonna pop in before the live stream, but that didn't happen. Okay, right, to be honest, I'm gonna leave it for a second. Maybe I'll get some proper tools in the meantime so I can focus on this. So, in here, I don't think I have any problem on the x-axis. I can move it across, there's no problem, it glides really smoothly. The only thing that is kind of stopping it right now is the bowden tube from move, but the bowden tube doesn't get tight or doesn't prevent it from smooth motion, so I'm quite happy with it. If you wanted to adjust, the adjusting procedure is that this screw at the bottom isn't I can show you that? Can I show you that? Should I show you? I'll show you guys, because you're fine people, so I'll show you that. So this screw isn't concentric, which means, let's see this one. When you twist that screw, you are moving it up and down. So you kind of create a squeeze between those two and the bottom one. These are concentric screws, so they stay in place, they don't move anywhere. But this one, when you turn it around with a Allen hex key, so on a Mac, when you're turning around, it goes either up or down depending on where's that deconcentralized part of it. So that creates a grip between all three rollers. I've disconnected the extruder, so that's why I didn't want to heat it up blocker again. Once I got a proper wrench, it'll be no problem. It's not caked or anything, it's just a little bit seized. What I'm needing is a adapter. And I bought myself a couple of adapters for this mini wrench, so I'll be able to do all Allen key sizes, which I couldn't previously. Right, that's fine, and I'm gonna need one normal Allen keys to kind of stop it. I'm usually better at this. Okay. I'm not in focus for some reason. I'm going to take it apart so I could show you. So once you kind of have a proper understanding of how it works, then you can diagnose stuff. And this, I'm only gonna take this one apart, because the rest of it is basically the same. So you're not going to. Oh, that's lots of dirt. Actually, I'm quite happy to take it apart. Come on. Nearly there. So if you take a look at this, you'll see what I mean. You can see it not being, you can see that knot going up and down when I'm spinning it, right? It's not concentric, and that what happens when you twist this this nut in here, the internal nut. It will allow you to move the wheel up and down and create a better biting point on your axis. So when you have it in here, you're gonna have a grip. Now I have a lot of crap. Ew. Just look at that. Go on. Ew. So yeah, it's a good thing I took this apart, just to clean up. Be nice. It's been, like I said, it's been a while since I did all that work. So yeah, you can. Can I do a little bit? You can see now the screw and how the hole isn't in the middle of it. Right. Okay, the wheel looks okay, it doesn't look damaged. I'm gonna have it, since the cage is taken out, I'll quickly inspect the other one. I don't see anything on there. So these two should be as hard as possible. well, I mean as hard as possible, like firm, so they don't have any play. And that's it. You start with those two being in place, and then you thread the adjustment nut. Yeah, kind of make everything align on the rail. Then washer, nylon nut. You can do it in your hands first until you get to the biting point of the nylon nut, and then it should be still enough space to kind of wrap around it like this. Ta-da! So now the reverse will happen. So you basically, first you need to get to the point where it's a little bit tight. And you have a proper grip. You can see, you can hear it rattling, but that's fine, because the rattle isn't because it isn't tight enough. The rattle is caused because it's not aligned yet. So once you're happy with this, don't make it too tight, because then it's gonna be harder to adjust the nut. Then you go for the nut which is in here. So you need to take, I think this is like 10 maybe, yeah, it's size 10, and then you just turn it. And then you just have to angle it that way that you don't have a play whatsoever, but it still glides really nicely. Yeah, no play whatsoever in then directions, and once you finish, just you can try to keep it in the position, the bolt in the position where you align the knot, and if you don't move your bolt it won't slip, and then just finish up with a gentle tap to the nylon nuts on it. Yeah, I'm happy. Oh yeah, you could heat it up with a torch. I have a torch somewhere in here, but like I said, I'm gonna wait for the proper tools. They should arrive. I have plenty of other things to check. I know the nozzle's fine, really. It's just I'll show you a nice way to clean it when you have it in these conditions. There's some cool tricks that you can deploy. Alright, so we have this. That's fine. The next step you probably want to check, since you have this, you want to check the axis. Now, I have a little more play on here. Can I like adjust this camera a little bit better for you guys? So I have a slightly more play than I would like on this. There will be in a little bit of sag because it's obviously not supported on this side. It's supported on this side by a lead axis, but lead screw, but on here it is not supported, so there will be a little bit of sag. So what you're looking for are first, if the nuts or the bolts that are keeping this attached to the actual brackets are done properly, so there is no play in that. If there is a play, eliminate the play. Well, obviously they've changed the size of the hex. So that was a little bit too easy to undo than I would like. Okay, not too much. And then I'll see if I can make it a little bit, to grab a little bit more. So I'm gonna make adjustments in here on that knot, just the same way I did it in here. So that's the next step. You can see this, right? Yeah, you can. So okay, I feel this is better. Maybe tiny bit. Like I said, you don't need much on this. If you did everything correctly, you don't need much. Now, while you're here, you can always check if all the knots are done correctly. It's probably skidding on the other side. My power supply is in the way. I should remove the power supply to verify this, because my power supply is on the way in here, so I can't put the hex into it. So let's do this real quick. If you don't have a power supply here, you have it at the back or at the bottom. Your life is easier. I'm taking the power supply not just because it's not the only reason I'm going to remove it, because I want to check if I don't have any play. Also, so I'm just gonna move my power supply. We're gonna be probably doing the cables as well. So another thing is the axis here. Check if your top is firmly attached and doesn't have any play. That's fine, I'm happy with it. Now I can confirm with my wheels. See if they're nice and snug. You should be doing this every, depending how much you print, but I would encourage you to do this every 4 to 6 months. Okay, I'm happy with this. That feels better. Now I can put the belt on, because I'm not going to do any more adjustments on this axis. So I'm gonna double check on this one in a second. That feels fine-ish, I guess. You have a benefit of having a lead screw in here, which kind of keeps stuff a little bit more firm. But yeah, feels really solid on this side, so I'm not going to do anything on it, so I can put the belt on. So let's put the belt back on. Make sure the belt tensioner is pulled in all the way, so it would be easy. Slot in the belt. Slot in from the other side. And then tension it. Now, you don't really need a lot of tension on the belt. For the belt to skip a step, it has to be really, really loose. In fact, if you tension it too much, you create extra resistance, which isn't good, because it will wear your component quicker. So your belt it's not a string on a guitar. It should be firm, but that's all. There's no way of kind of explaining it. I kind of just pushed it with my thumb a little bit, and that's all. That's all you need. Okay. My chat isn't okay. Right. I've checked on the chat. That's fine. Right. So once the belt is on, again, give it a quick move. See if it feels okay. It should be smooth. You should see the feel the stepper resistance. So it's obviously not going to be traveling as nicely as without the belt, but you should feel very smooth resistance. You could, if you close your eyes and move the stepper tiny little bit, you should feel the. I mean, you move your carriage tiny little bit, you should feel the stepper steps. And that should be consistent across. Alright, so we're happy with this one. Let's investigate the bottom one now. Again, same thing. we're gonna be taking out the bed. Now I have a magnetic bed with a glass surface. Camera, zoom out a little bit. So I've used a couple of those magnetic beds and peeled out the spare tape, the magnetic tape. I've put one on the bed and I bought another one and put it on my, what's it called, glass. And that way I can quickly swap these, which is nice. So for bed we're gonna be leveling it, so I can just simply remove this. Now usually you would be able to pull out the bolts through here, but I have a magnetic surface, so I have to remove entire surface in order to do it. Fortunately it's easy to do. If you want to unscrew your bits faster, just squeeze the bed a little bit and they'll just undo themselves really. Don't squeeze it too much so you don't warp it. Just a tiny little bit of squeeze. So I have orange springs just to make it a little bit shorter. Now when you put the bed down, if you're removing the bed, just check on the connectors, see if there's any damage to them, if you can see any cables being ripped or something like that. Investigate the lids to make sure it's not going to set itself on fire anytime soon. And now we have a carriage again, so same thing, undo the tensioner, once the tensioner is loose, just push it in a little bit, and then we're gonna undo the belts so I could see how is it gliding or if I have any play. Because if your belt is very tight, it will kind of equalize and it won't tell you if your carriage is sliding nicely. So it's best to remove this so you have a better understanding what's going on. So I can feel in here I have a bit of a bite. In here I have a biting point as well. The rails feel okay, so I need to investigate the wheels. Let's take the tensioner out and I'll be able to remove the bed. Alright. So there's a bit of a muck on them. I have this brush. Now on the bed you have two adjustment knots. Ooh, this is dirty. This is really dirty. I don't think I've done that in like 2 years. Which is hypocritical that I advised you guys to do it every like 6 months, and I haven't done this bit in ages. Yeah, that's a lot of dirt. Right, I'm just gonna give it a quick clean. And check if all the wheels. This one has a tiny little bit of play. Okay. This one's firm, so this one needs to be tightened down a little bit. Those things add up, guys. So I know you might be thinking like, yeah, but this is like a half mil in here, so you. But those things quickly add up, and they'll show. Where's my? See, this is actually more than I would like. I'm trying not to move my concentric screw in here, because otherwise you won't be getting onto the carriage. Okay, back to the carriage. No bite points right now. That feels really nice and smooth, I like it. Up and down, side to side. No, not everything is firm. If I wanted to, I'll put just which side is it? This side is adjustments. I could just see if I adjust them a little bit. I was loosening up. I want to tighter. This is too tight. I can feel the bite. Alright, I am happy. I am happy, so I'll just see if these ones are as tight as I would like, and I'll be putting it back together. It's actually not, it's a very relaxing process, and it doesn't last as long as you think. It's just, you need to have good tools, otherwise you'll be spending forever on certain things trying to get into place and stuff like that. So it's worth having a dedicated toolbox just for your 3D printer. And they don't have to be expensive tools, but they, just keep the tools that are specific sizes to your printer and you'll be happy. Yeah, I'm super happy with this, so we can put the tensioner back on. While you're here, you can check the belt itself and see if there is an issue with the belt. You can also investigate at the back. You'll have the stepper motor, and there is is there a group screw or just press fit? That's a press fit. I have some stuff on it. I see like a couple of darker dots. I'm just going to scrub them off, just to make sure they don't cause a skip. If your stepper gear, pinion gear is dirty, it can actually cause stuff to skip because the belt not going to get proper grip. Alright, so it's important to put the belt and not to wrap around the cables. I did that in the past. Oh, my camera. My camera just decided to disable itself. Oh, don't tell me it's a power setting. Let's see what happened. No battery, guys. I ran out of battery. That's fine. That's okay because I have a second camera. It's not going to be as fancy, but I do have a second camera. I thought that the battery is going to last longer, but although I can try one thing. Let me just get a USB cable, because this is the first time I'm using this camera for live streaming. I didn't know how long it's going to last. I didn't know anything. But they do have a charging cable and it has a charging functionality, which I should have probably enabled straight away. Let's see what's going to happen. We're going to try to charge it, because I don't have a dummy battery for this camera. That's the problem. Okay, I don't think it likes this cable, but that's USB Type-C PD. Let's check one more cable before we go to our regular content on a different camera. And I was doing so well. Come on. No? It shows the charging icon, but it doesn't show the... Okay, so I think it doesn't have enough juice to do that. Don't worry, guys, I do have a spare camera. I do have a spare camera, and we're gonna deploy the spare camera right now, which is powered, thankfully. It's just not as fancy, so I don't get all the fancy options. That's fine. I was using something else. the video feed cable. Ta-da! Okay, I can't see what's. It's gonna be harder to make adjustments, but yes, we are. Yeah. In case if you want to know what I'm using, it's a Lumix S1. This is an expensive camera with a kit lens that was 1,800 pounds. So yeah, don't start YouTube career with this. For the wide shot, for the wide shot, I'm using OBS bot, which gonna be reviewed very soon because I have a new one. So it's gonna be new tech. In fact, I was editing the video before the stream. Right, let's continue where we left off, which is installing the belts and tensioning. Make sure your belt, when you're reinstalling the belt, it's very easy to twist it. So try not to twist it, especially inside. I did that once, and when I firstly built my printer, and I could not figure out why I have such a big problems. Like, I'm not perfect with 3D printing and anything. I make mistakes as well. So it's a learning experience to everyone. We're following through video, and my nozzle has sheared in the heat block. Ooh, ouch. So yeah, as Frank also said, yeah, with the tuning on with the belts, with the tensioning of the belts, like, you only need a little bit. If you want to find out if it's skipping, there is a way to, on this side, to block the motor. So that's why I didn't want to. Come on, focus. There is a way you can block the motor, stall it, and try to pull on the belt and see when it skips. And you'll notice that yeah, it's very difficult to make it skip. Right, we were on this one. So here right now, obviously this is too loose. that much is too loose. So again, just pull it with your fingers a little bit. You'll feel that it's then, like, that's all it takes. Like, I can easily press it. I'll have to put in. That's honestly, that's all it takes. Don't. If you tension too much, nothing's gonna immediately happen, but you will wear down everything quicker. So it's just a sensible thing. Plus, another thing is, you will stretch your belt. If you stretch your belt too much, right, what happens is the gap between individual teeth on the belt widens, and it doesn't mesh with the pinion gear. So when the pinion gear rotates, if your belt is stretched, it's likely to skip. So if you, like I say, if you over tension it for a long time, you'll stretch the belt and you'll have skipping on the belt. So that's your thing. Like I say, nothing's gonna explode. It's just your component's not going to last as long. Alright. Now, while I'm doing this, I'm also watching the stepper at the back to see if everything is aligned nicely. So whether the pinion is in the middle of the belt travel and it doesn't, like, travels across. I feel like I have a tiny little bite point, and I don't like it. Like, you could see that when I'm pulling it, it will stop itself. I'm just gently grabbing it. You could see it kind of stops, like in here. And this is the alignment of the wheels. So I'm just gonna do it one wheel at a time, just a tiny little bit. I need to figure out which direction first. No, that stepper motor is strong enough to overcome this, so like I said, I'm being OCD about it. But since you're already there, you might as well just do it. Okay, now it's gone. I'm happy. I can reassemble this again. So, orange springs. Would I recommend it? Maybe. Honestly, the springs, I don't know. They compensate for stuff that you can't do. I say. I have them on my each printer. It's because one time I bought them and I thought they're gonna be amazing, but they were just springs. So they're slightly stiffer, and to make it right, you have to kind of squeeze them all the way up until you have like a less than a half a mil between individual coils. That'll give you a bit of rigidity, but it also give you that extra what is it called, that extra plunge. So you'll be able to squeeze it up and down, you'll be able to move the bed up and down, and when the extruder crashes into your bed because of something, you'll have that a little bit of play. So you don't have to give it much, but the more rigid you're gonna squish it, then the less time you'll have to re-level the bed. Don't, like I said, don't also overdo it. Don't do one at a time. Do everything like one corner a little bit, then another corner a little bit, because that will prevent you from warping the bed. And you want to look after your surface. There's my fourth wheel. See, that's definitely not, that is too loose. Okay, and now I just need to find my fourth wheel. I have it here somewhere. Where is it? Is it dropped somewhere and I haven't noticed? Ah, here. There it is. Can I show you this easy way? I don't think there's an easy way to show you this. Just doing a little bit at a time on each corner, so I don't introduce the stress to material. And once kind of you are close to the proper squish, just leave it, because you're not going to get perfect right now. Okay, let's see if I can show you this. What I consider to be a good squish, the beginning squish. Come on, refocus yourself. I have focusing problems. Oh, come on. Should be able to grab this. Yeah. Okay. So you probably want to aim for something like this. So that's the kind of squish I would be advising. Enough to get it quite rigid, and leave a tiny little bit between each coil so you have this play. Right. Let's go to kind of overview. We focus. Okay. I never used the silicone spacers. I don't know if they're better, honestly. I think if you mount any springs okay and tension it correctly, you'll be fine. You don't have, it's one of those upgrades that is kind of, you think it helped you, but it wasn't this. It's just one of the things that I always tell people, if you think that your upgrade just fixed a problem, on the printer that should be working okay. It wasn't the upgrade that fixed the problem, it's the fact that you disassembled things and reassembled them again in a proper order and with a proper care. So most likely when you, for example, a lot of people had a better experience with the orange springs, and I believe only because they bought the springs, they replaced the springs, and during the replacing process they actually tensioned them and paid extra attention to tensioning them correctly, and that basically made it better. Right, so we have it this. We know that my extruder is not moving. We're still waiting for that my nice wrench that we can use. There's a couple of things that we could really do. First is the cable management, because this is not bad, but the back of this printer is horrible. Another thing that is really horrible, when I was writing my article about silent 3D printing, I didn't pay attention to cables, mostly because the cables didn't matter, right? For me it was like, yeah, that's fine, I'll reconnect two different fans in here and then I'm gonna do something else, etc, etc. So that was one of the reasons I didn't pay attention to the cables. Now another mechanical thing is obviously extrusion. Now extrusion, what you have to pay attention to when it comes to extruding things, can I just like get maybe reorient my printer a little bit. Let's hold my power supply. No, that's gonna make it's all the way around. I want. No. I should have made my 12-volt power supply on the connector as well, so I could disconnect the power supply, which we might do actually to make our life easier. So it's probably this, so it's gonna, yeah, that's gonna be okay. Let's zoom in, position the camera a little bit better. So here is the extruder. I have a metal one. Metal one is nice because it doesn't get damaged as quickly. Oh, it's aluminium. So there's a couple of things. This is dual gear, which means, well, dual pulley, well, gears, which means the shaft, the main shaft, will. Can I have a better picture of this? Just because I'm not showing this well, and you deserve to be shown this well. Oh, that's better. I like it. Can I have like a close look? Can I go lower with this tripod? Yuck. Yeah, look at this. Oh guys, we're gonna have such a beautiful look, right? View onto that printer right now. Let me just. How's that? That looks splendid. So, this is a dual gear. Dual gear, the function is that the main shaft, the main pinion, is driving the other one, so those two rotating. So this is what dual gear means. So they're both actually actively working to push the filament through. Now, if I disengage this by pressing on a spring, you'll see that this one I can rotate freely. This one, the second one, and this one, it's not engaging either. So they're both squeezing the filament, and that's important. They need to squeeze the filament, so this is the spring, tensioning spring in here, that allows them to have enough friction on the filament to move front and back. So if you see, if I pull on the filament right now, when you do this, you can tell it's nice squeeze because they're rotating with your filament. If you do it even quickly, you should see this rotating every time. If that skips, you need to work on your tension. So this is a tensioning mechanism, and you just get Allen key, and then you can just drive the pinion in and increase the tension. So when you're increasing the tension, you're pulling on that lever, the lever closes that gear, so the both gears are very tight and snug together, and you create a tension, correct tension. That way you don't have under extrusion, because if your extruder skips, then well, you don't get enough filament inside. Now if you have a single gear extruder, that second gear which is in here, it's replaced with a roller. So you have only one press It presses against the roller rotates based on friction, and it's even more important to get the tension right because you're only squeezing it from one side instead of pinching it from both sides. So this is the biggest advantage of this type of bracket. Plus in here you get less of a wear because on my all enders I've seen the filament just chewing through the plastic and just ruining the part. So yeah, if you want to adjust it, that's the part, that's the first thing. The second is to check this screw in here, which will also prevent this from excessive movement. As you can see, it feels alright, and we'll just double check it with the hex screw. Yeah, I could apply a little bit of tension there, and I don't have any play on there. That's fine. I'm happy with this, okay? Right, another thing when we're in here is to check your lead screw and all the dirt that you accumulated in here. It's not going to matter as much, but if you are here and you're doing maintenance, you might as well, because over time you'll get a lot of crap in here, and that can at some point cause to excessive wear. It probably won't stop your printer from moving, there's way too much force on it, but it will cause excessive wear. Excessive wear will cause the play, and the play on this axis will cause Z axis to misbehave. So this is brass, so that's going to wear over time as well, so it's good idea to check the wear or play in here. You shouldn't have any play really in here, it should be nice and snug. If you see this rattling, then it's time to change that lead screw knot. Make sure this also, those screws that's in here, obviously different size, because why not? It's super tight, so because they drive anti-axis and the side about your Z. Yeah, it's just screws in here. Right, we're good with this. Come on. I'm happy. Now, another thing that you can investigate is at the bottom. You have in here you have the coupler. So this couples the Z-axis, then step out with the shaft. And all you have to do is see if it's not skipping and check the tension on those two drop screws. Yeah, that's fine. Happy with this. Alright, so we've been through a couple of things. We know that the frame is rigid. One side maybe someone's going to notice in pointing it out, but I'd like to tell you something interesting. There was this big online debate about this particular part in here. You do not need this. There is I have it in here for completely different reasons. First of all, you don't want this rod to be too tight on this, because if you have it very tight and fixed, you can see there's quite a bit of play on that. It will cause this to bend, and you want this to be straight and create its own kind of tension across the points between let me readjust the camera. So you want this rod to kind of create itself a direction and tension between these 2 points. You don't want to create a third point. So this is fairly loose, and like I say, goes up and down and side to side because it's threaded through a bearing, and it doesn't really touches the bearing, so bearing doesn't really rotate. The reason I have it is because I take my printer to Hackspace and with me sometimes, and this lead screw is quite fragile, so if you grab it by mistake or something happens to bend it, it's quite easy to do it if you don't have any protection in here. So it doesn't really add anything to your printing performance, but for the transport reasons I have it in here, so I have less chance of damaging my lead screw. So if you notice these on the 3D printers, like I said, this is basically a transport improvement, nothing else. You don't want your screw to be pinched in 3 positions because it won't do you any good. Okay, so now we have this monster, which is a massive power supply. I can disconnect some of it, but unfortunately on the last trial, when I was adding stuff, I was not there, or I hardwired a 12 volt power supply. I can disconnect it from inside, but I have to still take this part apart, and that's obviously not ideal. I want to have a proper connection in here so I can just pop it out. Another interesting thing is that inside I have a Shelly device, so I can turn the printer on and off from a distance if I want to. And that was obviously, you can see that this is a part of my power supply mod, so it is very quiet. In fact, this is what you need to modify. You don't need this part, you just need a power cable. I'm using this to be able to control the speed of the fan, but the Noctua fans, they come with a 70% cable, so the cable that introduces extra resistance and drops the voltages, and at 70% it runs quiet and there is enough flow that blows the air out through here. I had no problems with the power supply, which is nice. You can see I tapped in parallel to the mains. This is a charger in a custom, just a normal USB charger in a custom 3D printed enclosure that provides the power for Octoprint or lights depending on what I'm using. And also there is another connector that I probably should be changing, which is here, and this is a very lame cable. I don't like it. I should really get a proper cable in here and route it. Another thing that bothers me is that in this orientation, when my screen is in here, I can't use my light properly because the light comes in front of the touchscreen display and makes it hard to operate. So I need to figure out where I'm gonna put the display. I need to see if I can actually drive them in a different orientation. If I can drive them in a different orientation, I'll be able to maybe play a little bit with different fittings and how to adjust it, or maybe raise it. But yeah, for now the screen is here, and obviously it's not a stock screen. But yeah, I need to figure out how to route the cables properly, because I don't like the cable itself and the way it's connected. It doesn't have a proper socket on the other side. It has just the DuPont cables, and I need to turn that into a proper connector. Now, let me have a look if we have anything from Amazon coming yet. They promised they're gonna deliver stuff. So let's see. If not, we're gonna start taking my nozzle apart. Come on, my orders. Out for delivery, 5 to 7, okay. This is 4 to 6, and this is 5 to 7. Right, okay, so they're probably not going to arrive in time, which means I'll show you the nozzle trick now. What you want to get is M6. So this is to clean your block. Let me just redo the camera. I know we've been doing that for a bit. So to clean your nozzles, this is a very neat trick. Get yourself a threading kit to make threads. It's brilliant because one of the hardest thing is actually removing the thread from threaded areas, right? So you get your internal tab and you get your external tab. So where's my tray with nozzles? I'll show you on there. A spare nozzle. Oh, come on. Oh, actually I've cleaned this one. Will I be able to zoom in? I don't think so. See? So this is a used nozzle, but you can see the thread is fairly clean. And the reason why the thread is clean, because this is the reason. You can see actually a filament from the last cleanup job. So when you put the filament nozzle inside and you start rotating it and threading, it doesn't create a new thread because it's obviously the M6 is already created in there, right? But it scraps everything that is on the thread and it gives you a really nice and clean thread, so you don't have any plastic in here. And the same goes for the other side. So if you have a filament block, right, and you want to clean your block, then you get internal tab. And again, it's not going to, this is M6, it's not going to create a tab inside because your block is already tapped for this. But you will be able just to scrape it from plastic and then make sure the next time you're going to put your nozzle on the block. So next time you're going to put a nozzle on the block, it's going to be, you know, just metal on metal. It's not going to be any plastic preventing you from having a seal, because if you used it with the plastic, and you probably did it cold, then you heat it up, that plastic will melt and you lose all that friction that you had between the thread, or start oozing out, etc., etc. And that's one of the really cool tricks on how to sort it out. Now, I probably need to heat this up, so let's do this. Let's heat this up a little bit, so I will be able to do this part. So I'm not going to connect everything, just the bits I need to get this done, which is a power supply, which is where's my, let's flip it around. So for the power, for the heater element, I used X30 connectors. They're really good. You can see it in here. Tiny, and it's perfect for this. They don't really have polarity, so unless you have some like custom stuff that for some reason has the polarity. But those don't have the polarity. Same goes for the thermistors. They're just resistors in a wire, so they don't have any polarity. And for the resistors, I used micro USB because I can hook up 2 fans and the temperature probe to this. I'm just gonna connect this. Right, move the stuff that I can melt on the other side and away from the stuff that I can short things. Right, now I need the main power supply. Okay. Cool. Now, because we're going to be heating this up, you probably want to grab it in something like this. And then let's heat it. You don't have to heat it a lot. I'm gonna just do it like 100 degrees or something. That'll be enough to loosen things up. Heat nozzle to, there you go, 100 degrees. And while this is heating up, I'm gonna take my really crappy tool. This is a hardened nozzle. Like usually I would use for the normal nozzles, I have this, and this is perfect because you can just ratchet it out. But this one only have like 2 flat sides, so I can't use the ratchet. Right, this has 90 degrees, it should be just... Oh, bloody hell. Come on. Just see properly. Okay, preheat. Let's increase the heat a little bit, 150. Now be careful, because you can burn yourself. Okay, that's done, so we can start cooling it. Well, before we start cooling it down, I'll do the other side. Honestly, I would recommend the tap. Oh, that was easy. I'll show you on these ones how easy it is to clean these now. And the thing is, you don't even have to run them hot. Let's cool it down. So I'm not going to unscrew them until they cool down a little bit. There's no point. And I can also use the temperature to kind of know when it's safe to touch. But yeah, but the tap, it's really easy to do it. And I bought them for something else, and I was quite surprised that it works so well. For the brass nozzles, you're probably not going to need it as much, because brass, if you clog it, they're inexpensive and easy to replace, and it's probably gonna be a time to replace it anyway. But if you have like a hardened steel or something more expensive and you just properly clogged it, then yeah, that's probably one of the better ways of doing it. Okay, well, we have 130 degrees. Okay, we're getting there. I'll take a small. It's already loose, I just don't want to hold it in my fingers. I'm going to take small pliers and just remove it out so it would cool down a little bit quicker. There you have it. I'm not burned. That's nice. It's a bit caked. I need some cleaning. Wire brush is good on a thread that you probably just spin stuff around, which might not be ideal. Especially you want to make sure that this edge next to the, zoom in a little bit, that this edge here, you want it clean, because that will determine how deep your thread can go, and you want it to have it like a nice seal. Okay, so now if you want to keep it nice and clean, just do this. And you'll feel slight resistance from it, which means it's scraping the plastic out. And then just bottom out all the way and go back. Now when you're threading it, you probably, this motion is when you're creating a thread, and so you don't break your tools. And you could see a chunk of stuff just fall down in here. Looks a little bit better. Probably want to add a little bit of knife action. Let me just get my small knife and make sure there's a neck which I can't really reach with my tool. I can just scrape it off with a knife if I need to, so that's fine. Those tiny things will make getting a seal harder, so that's why it's important to clean it properly. Okay. Now with the nozzle, exactly the same. What's the temperature on that? 82 degrees. I'm probably not going to enjoy keeping that in hand just yet. can feel how gummy it is because it doesn't have that that nice ability to kind of like slide metal against the metal, right? So I can feel that kind of gummy. Same thing, M6. All the way in and back out. Oops. Yeah, the thread is clean. Now you want to also make sure that the top surface of this surface is nice and flat, because that's what's gonna be touching the heat break. It's not as important as having this neck cleaned, to be honest. I mean, I'm here so I can do it, but okay, happy. Now, block, what temperature? 60. I should be able to touch it. Yeah, okay. Probably not going to hold it in my hand very long, but it's not instantly burning. So with the tap, it should depend on the block, but you don't need it that much to clean it on. You can really just use it with your hands to tap it out. And I can see the metal now on the inside, no plastic. And if you really have OCD, then you can scrape the rest of it from the surface, so it looks nice, doesn't gum up the silicone sock. Probably gonna buy a new block at some point. It's been a while. I mean, by while I mean never. Okay, so now this is the bit that requires patience, because you want your heat break to be all the way in. So this is what you're gonna do first. You want to screw that in all the way, maximum, as far as you can. That's very good. That's pretty quick. This is where I need proper tool for this, because the harder I go with it, the more it opens, and it's crap. You can't do it properly. Right? So obviously I'm not going to make it properly without holding it in something. I could remove the heating and the temperature probe, but I'm gonna leave it in because of the next step. If you want to do it properly, you could put it in a vise and use proper tools that will make it work well. I squeezed this tool too much and now it's too tight. So I can't get around to open this. Come on. So the reasons we are driving this all the way in, because we're going to be pinching this from the top. We're going to be closing the gap with a nozzle. So when you have a nozzle, you'll literally touch on the other side here. The nozzle shouldn't go all the way in. Should be a little bit of space left. Now if your nozzle goes all the way in, then you can't screw it any deeper because your neck preventing you from doing it. chances are your heat block is like a third-party heat block or something like that, was too thick, and well, you can't really do it because you're gonna have a gap in here, and that gap isn't healthy. So the way to measure it, if you have a correct, I'm going to show you this. Let me just open this first. And where's my small pliers? Okay. You kind of can measure it. Squeezed it so much I can't really open it now. Just like a fraction of a millimeter. It's really annoying. I'm just gonna undo this. I'll show you how to check this. For the first 3D printer, it depends really what you want. If you are planning to upgrade later, I'd go for the Ender 3, right? And then you'll save yourself money. If you want something that will be really good from the get-go and you're not really interested in getting it better later, then V2 might be a better idea for you because it kind of starts there. But then if you want to upgrade the V2, it's a little bit more convoluted. So the way to check it is if you press this one against the nozzle like this. So if you try to get your heat block pinched between nozzle and the heat block, sorry, heat break, there should be a space. It should fit comfortably like this. You see, those two have to meet inside. So if there is a gap in here like that, if you would have a small gap, you'd have a filament problem. So you want to close this gap. If your heat block is too big, you can put a chamfer. You can get one of those chamfering tools and just dig it out slightly so you could drive the nozzle end further. So that's what you do it. You want to get your heat break screwed in as deep as possible. And make sure that the neck on the heat break touches the touches the heat block, right? So there's no space, it's flat against this. And now, when you adding the nozzle, when you finish it and when you feel really tight, you should have, this is obviously not done yet, but you should have a small gap in here. There should be a tiny little gap. Because if you close the gap and that goes all the way flat, there's no guarantee that there isn't like a bubble inside where the filament can expand and cause problems. So this is why. So now that you do that, see, I have it's a very small gap, but I can see it, it's there. I'm confident that the filament and the nozzle, it's pressing against the heat block. So now that you did that, it's not over. Now we have to heat it up. So let's heat it up. Menu. Want to see my fancy screen? So let's go, this is my fancy screen. We can heat it up. Let's go with the preheat options. Heat fan, preheat. I want to do only nozzle and let's do PLA. So now it's going to be preheating for PLA. It's 200 degrees. Yeah, let's have a look. What's the best block to buy? Well, you can buy individual blocks like this and then add it to your existing extruder, or you can add you can buy entire extruder. It's up to you. It's obviously cheaper to buy the block, but if you're buying an individual block, then you'll have to make sure that it's thinner than the rest. Okay, this is smoking some plastic. right now, that's fine. So we are heating it up, and let's go back. So this is hot now. So now, if you're brave, you should really do it while this is slightly, or at least hot a little bit. So clamp it with something, and like I said, my tools. See how easy it was for me to move this? It was way too easy. So now, just make sure you start with, you can slightly undo the nozzle, but basically repeat the entire process. So redo the heat break, and I really wish my tools would arrive by now. Okay, and do the nozzle. Don't burn yourself, which is always important. Okay, and then we can cool down. Make sure that doesn't touch anything. Okay, so now that should really nicely close. We shouldn't have any problems. I can see there is a small gap on the nozzle end, which means it's pressing against the heat block. It's not against the heat breaker, not the heat block, so I'm happy with this. Okay. Once this cools down, we can just put that back, and we'll be able to reassemble the Hotend. No, without the fan it's going to be taking a little bit longer to cool it down, but it will happen eventually. You can use pliers actually to kind of maybe slot it back in a place and take advantage of that. I'll pull the filament first, because I had a bit of a cold extrusion in there, so I'm just going to pull the filament. No, first I'm just going to pull it through, cut it flat, not to burn myself. So if you do a cold pull, you're going to end up with something like this. I don't want to focus. You see, this, we know what it's like shaped. I'm not going to say it on live stream, but we know, can imagine what it's like, what it's looking like. And that will prevent you from pulling out through the bottom tube. So when you removing filament, just heat the filament first, push it, and then immediately pull it. So you'll end up with just this bit getting thinner. You're not going to end up with this bulge. That's the trick. Droid. Yeah, I know. I want to get rid of this. I've ordered, like I said, they are coming. They are coming. They are coming. Proper tools. Look, guys. I find it. Where is it? Where's my Amazon? I've got. These are coming. So those are from like size 3 until size 10. Because I have like a big one, so I don't have a, like normally if that was a normal if that was a normal end, what is this? Like this. If you see, this has a hex head on it. So then I can just do my super cool number 6 ratchet. Like that, fits perfectly, and yeah, you go all the way. It's nice and fun, you get it nice and snug. But with the hardened nozzles, they are flat on the side. So I'll show you the hardened nozzles I have. Ooh, actually, scratch that. I found that's a hardened nozzle, and it's I might be able to use this one instead. Oh, let's go for this. It means I'll have to redo it. Yeah, I'm going for it. This is a hardened nozzle, and it's 0.4, and it's hex. I'm liking this because the other ones I must have it from my last build or something. My other nozzles. Anyway, that's what I'm going for. I didn't know I have this, so now I can do it properly, guys. Or is it number 6 or number 7? Number 7. Yeah, look at that. Now I can do it properly. I'm happy. Which means I have to undo my progress on this side, which is, yeah, but basically, yeah, once it's cooled down, it's 100 degrees. You shouldn't be able to, it's difficult to remove it right now. Which was the point of the exercise. No, this is for the break. Come on, where are my tools? I want a proper tool. That's what I'm saying. If you get proper tools, it takes you half the time. Can't believe them actually. Yeah, this is stuck. Don't you hate things? But yeah, but basically, yeah, if I'm gonna heat it up, it's gonna be better. Nozzle heat PLA. Yeah, I go. I'm gonna swap it for the other hardened nozzle because the other one's easier maintenance, and I like that you can just do it this way, and it's easier. Because when you want to remove it, you just let's go like this. When you want to remove it, you can just go from this side and it's done. What filament are you using? I'm using my filament is for my hardened nozzles. Where is it? Here. No, this is not this. This is because it's an empty spool. I'm using this. This is Onyx by Marked Forged, and this is 800 grams of roll, and it's around $200 per roll. So it's an expensive stuff, but I get freebies from my work, the leftovers, and that's just enough to get me going. So I'm quite happy. So if I like, this is I can show you a sample printout. That was done with it. I'll show you in a second because I have it. This one is heated up now. I'll be able to disconnect it. I'll show you. Okay, let's get my super extra cool tool that no one should be using. I see it worked now. Okay, we're gonna perform this operation on a hot block because I like to live my life dangerously. Okay, I think it's out enough. Come on, out. No, go up. Okay, can't do it. Didn't want it to destroy my magnets. And we're gonna take this super extra uber cool hardened nozzle with a square. Now, if you're quick, you won't get all the heat straight away, so I can start it like this and then finish up like this. Ah, nice. I'm quite happy with this. Let's investigate up close. Yeah, I can see a tiny little gap. Subject to testing. Let's cool this down. So cool down. I'll show you the carbon carbon film. Oh, I have a cat. I forgot I have a cat printer. So this is printed with carbon filament. It's a nylon with carbon fiber. Come on. It's really cool. And it has a good temperature resistance. So yeah, that's what I'm using. Alright. Okay. So once this cools down, we're cooling down, yeah. Then I can mount it. I have a nice new nozzle. And we'll be able to assemble it. So I'll just pull out the filament, since I can now. Reorient the part, might be able to have a cheeky mount. There's a bit of a plastic in here that just got mounted. I don't think I can pull it out. Would be nice to get it out. Come on, plastic, get out. Yeah, cool. That's nice. Now we can push this in gently and secure the group screw. I'm just gonna use this to push it against up, and then there we have it. It's mounted. It's mounted. Now it looks, all the axes look stiff. Should be nice. Shouldn't have any problems. Okay. Hopefully this is no longer warm. Yeah, that's fine. I can put it to my box because there's nothing wrong with this. Just next time when I'm gonna buy a nozzle, I'm going to buy one that uses socket because it's easier to use, honestly. It's just things that it's worth spending money on. Because these are crap, like anyways, you said on that live stream as well. Okay, so we went through pretty much everything that I needed. Now there's a couple of things I probably should take care of, which, as I said, just cable stuff, cable management. So for the most part, I have no problem. Just gonna zoom out a bit like this. So for the most part, I have no problem here. Like in here, it's really neat. There's some cables at the back. So what you want to do with the cables, obviously, have them not impeding your movement, not creating extra resistance, not not getting in the way, and not rubbing it against anything, because that will weaken the cable and break stuff. So that is kind of the goal. If you use the Bowden tube as a kind of a guide, you can just drag the cables wherever you want and keep them neat and tight. One of the reasons I went with the custom adapters was to kind of also limit how many cables I need to route, because you can share the voltage rail for your fans. I have a custom 12 volt, so I'm sharing the same voltage between all my fans. The power supply for 12 volts it's in here. I need to 3D print a nice cover for this at some point. But yeah, and then I have a dedicated 2 lines with X30 connector for the heated end. Can I just kind of move you a little bit to the side? Need to be kind of like aligned properly, not with this tool, with this tool. It's not straight. Tiny bit, that's fine. So yeah, I can put my shroud on. So let's do that. Now I need to replace this cable as well at some point, because right now I have this potentiometer. I already established that 70% is enough, so I'll be running this. There is a 70% cable I can run, just need to solder it properly, and then I'm going to replace it with, so it's going to be even neater. Until then, I don't mind having that custom adapter. So let's put that back together. We need my BL Touch. Now BL Touch should go first, and then you go with the shroud, because that way BL Touch is firmly against the base of the thing. So this is annoying bit. We kind of have to get things aligned properly. Because you have a very little space in here, and it's very tight with screws, so it's not so easy to kind of get them in position. But with a bit of patience and swearing, you'll get there. I promise you, you'll get there. Oh, like this. Just pinch it a little bit. Just gonna put it in the bracket straight away, because otherwise it just hangs and creates an unnecessary drag. Right, let's do the second screw. This is harder because it's gonna drop a million times, because there's almost no space in between those things. Yay, actually went easier than expected. Now another thing that is worth doing, or keeping in mind, if you have a BL Touch, and zoom in, and I need some angle on this. So in here there is an adjustment screw for BL Touch. Now on one of my brackets, this hole in here was too small. I needed to re-drill it to make it bigger. Now my BL Touch wasn't extending always, so it was having a problem extending. And adjustment screws, if you adjust the screws, it was working fine, but then when you put it against that bracket, the adjustment screw was sticking out, pressing against the bracket was pinching it in here with those two screws, and it basically ruined my BL Touch as an adjustment, and the pin was sticking. So you have to make sure that the hole in here is bigger than the group screw that is inside of the BL Touch for the adjustments. So if you have any problems with BL Touch not extending or hiding, check for that first. Separated my bolt into the Hotend cables, routed my hot side, and then zip tie mounts to the gantry. But I've ended up not sure able to do the basic and well, you could in theory do that. Right now I have a completely different setup because I have a water-cooled extruder on that one, which I'm gonna be editing video for soon. But yeah, you could do it. Like, there's no particular benefit of doing it this way really. It's just clean, and I prefer it. So yeah, okay. So we were screwing that in. So let's finish the job. Now, if you are playing, it feels really difficult to screw in. Don't think that kind of went into the hole in the right angle. So, if you are, I was gonna say something and I forgot. If you took your extruder apart and move your BL Touch, you'll have to re-examine your Z-axis, Z-offset, sorry, because chances are that your BL Touch is now slightly lower or slightly higher, and obviously you don't want that to be slightly lower or slightly higher. That feels really stiff, don't it? Okay. So I I bet you that my BL touch is now in a different Z offset that it was. It's going to be minimal, but that's minimal enough to ruin your day. So bear that in mind. I'll put my controller back in. Plug that in. Again, I'll make the custom cables at some point. It was very useful for testing the speed of this fan and see if it's affecting me or not. Alright, a couple of zip ties to finish this off. I'll make a custom shroud for this. Yeah, that's what I'm going to do at some point, to hide all the cables. And yeah, we are pretty much done. Now what we have to do is put the power supply back in, where it belongs. And the power supply belongs here. So let's find the correct screws for this. Which one was here? Okay, let's be clever about this. So much easier, so much quicker. And where's the second screw? I'm gonna take ages now to find anything, am I? Let's clean up my environment slightly. Don't need this, and don't need this. Where's the other screw? Where did I put it? Can I put the bed? Magnetic, nice, done. The sock on. My end is cold enough. It's easier to put it before, but it was hot, so I wasn't really keen on doing that. But now it is relatively cold. I can play with it. Again, sock isn't needed per se, but if you have a failed print, it can save you a bit of messing about. I bet the screw is underneath it. No, it's not. Ah, there's the screw is here. You should have told me the screw is in place. Come on, guys, are you watching this or what? Alright, guess we are ready for some action. And put my rubbish tools away. Get my good tools organized. This Veracet is really nice. It's not the cheapest one, it's really nice. I just ordered a couple of extra bits to kind of accommodate the sizes I need for these. I don't know why do I needed so many Torx but not a hexes. Whoever was putting this set together should go to hell for that reason alone. But the rest of it is fine. So the extra bits like £6, can't really complain. And it comes with the tiniest little thing. What did you do to make your bag? Like, I bought the magnetic bed, and the magnetic bed is that flexible one. And the magnetic bed comes with a flexible bed, and it comes with a extra sticker to put it on your regular bed to make it magnetic. So I bought 2 of these, so I could use two spare ones. So right now, like, can I do this? So this This is the original magnetic one. I can just swap it and I have a magnetic one. Or I can just have a glass one if I want to, so it's easy. But yeah, but they come with extra, what's it called? With extra stickers. And the extra stickers, if you buy 2 magnetic beds, you'll be able to do this, and then, I mean, it's only useful really sometimes. So I like it. That's one of the mods I did on my printers to make it nice. Okay, so let's have a go with this. Let's connect the main power supply, which is here. Let's move maybe this a little bit. Come on, camera. And you can see this, yeah. Let's put my USB back where it belongs. Which is here. We can put my light, which I should cable manage at some point and make it more custom. But it works well, so I like it here. And if you plug it in, it'll give you some light. Come on. Ah, there you have it. Look at this. It's beautiful. Alright. Then we need to level the bed. Level the bed. Have you leveled the bed? So quiet, isn't it? Now we need advanced leveling technique, which is this. Okay, I have special menus for the leveling, which is very handy. I can show you that. I'm gonna do like this and like this. And like this. See, that makes it super easy to level. All I have to do is just press the buttons and it will go to position and do its own thing. All I have to do is just kind of, so I'm gonna be pressing on each corners and you'll see what happens. Okay, so it thinks it's here, okay. We're nearly there. No, it's too. I need to apply more pressure on each one because the springs are a little bit too loose. Okay. The same goes to the back. So right now it was quite high and I was running out of place. Didn't want the springs to be that loose when it goes up. It's good to have a bit of a good squish Okay, and let's home it again. Yep, okay, now we can go leveling 0.1. Now something happened. Don't know. I must have maybe moved the cable at the back. That's why I wanted to change this. Okay, movement, home. I'm not using a stealth chop yet. This is all the default settings on the motherboard. This is just my. If you can I like do it in any efficient way? Go to my website and 3D printing, and then there is this little nice article that I wrote called Silent 3D Printing. That's what I've done. Leveling. Let's go. Super advanced paper technique. Go on. Okay, so now it's too high. I like it because now I can just release tension a little bit more. What? Seriously? Still? Okay. The problem is my Z offset is so messed up right now that I need to do Z offset first. I thought I was gonna get away with this. So let's see, what do I have on the Z offset? Settings, machine, parameter. No, not parameter. Oh no, ABL. Where am I going? That was in the ABL. Movement, ABL, maybe Z offset. So right now I am on minus 4.4. That's way too much. Just gonna do 2.9 and then home it again. And to this one still needs a new version of the firmware to kind of make it a little bit better. So it was pressing way too much. Tried using Noctua fans too. They can't handle the heat from the Hotend. It clogs. It depends what you do with it. That's the thing. Now I can run Noctuas fine. It doesn't clog. I'm running them at 70%. You have to have a nice part cooling thing, but the reason, I think one of the reasons it works well for me because I have an all metal Hotend, so it has a slightly different heat profile. So the actual the heat breaker transfers the heat differently to the standard one, and that seems to be working fine. No, leveling. Let's go again. Now I should have enough. Yeah, okay, so. Really? Still? No, it's too high. So, okay, my Z was maybe. I went a little bit too low. 3.5 maybe. I don't have the a menu in this screen to do the Z offset, so I'm just kind of eyeballing it for now, so I could have a leveled bed and then I'll do the Z offset properly. Come on, hold. Your Hotend has 250 watt heaters. What's the maximum temperature you're running this? I was testing this to 275 to be honest, because that's the hottest filament I have, and that was fine. It will also depend on, you know, the speed. I'm not interested in speed at all, because I'm okay when you think about it. If you're gonna run the print for like 24 hours or something, it doesn't bother me if I have to run it for 24 hours instead of 20, because at the end of the day you're still basically spending a day with the printer, so I'd rather have it to run slower and silent than faster and loud. So that's kind of my motivation behind it. Okay, this is fine. I just want to get at like a ballpark level before I'm gonna start nailing down my Z offset. So this is still too, the difference is too big, so, oh god. Okay, I need to do the Z offset correctly, because I'm getting around in circles. That's homemade again. So basically, that I was trying to get away with not setting a Z offset yet, just to keep the bed leveled, and then have a more or less straight bed, and then do the Z offset properly. But it's not needed. What you have to do is basically kind of mark the spot where your BL touch go. Alright, then move your axis to that. So for me it's just X. It's fine. So let's move that. You have to position nozzle more or less in that place. Yeah. I'm happy. Now you have to go to 0 on the Z-axis. Okay, so this is 0. And now I can tell that my nozzle is about 2 millimeters too high. So I need to add 2 millimeters to my current offset. I'll go to APL, Z offset. So that is 450, I think, right now. Interesting. So now I'm going to home it again and repeat it. Well, I have 2 printers in here, so if I'm printing anything, I can't shoot the video. Now I can, because you can hear how quiet it is, but previously it was quite loud. I could not shoot the videos for that many hours while a print was going, so it's just one of those things, isn't it? Okay, let's move it back to position and verify. Okay, moving 0 to 0. How much? Ooh, tiny little bit, maybe half mil. BL offset, so increase to 4.8. Let's test it. So I've moved the BL touch quite significantly here, because I just moved it, I think, about 0.08, sorry, 0.8 millimeter from the last. So that's important bit. All the way down. Okay, we're at 0. And now we're getting results. Hey, perfect. There's maybe a tiny little bit up. It's a little bit too much squeeze on that. So level ABL, the offset. So 4.8 was slightly too big. So let's go maybe 0.5 decrease. 75. Okay, and I think that's going to be alright. And then I can level the bed, and I'm done with the mechanical maintenance. And this evening I'm just going to look at the cables, and I'll be doing cables. The steppers are only loud when I'm driving them to the point, because I've increased the speed. That's all it is. When you're printing, you can't hear anything. My next video that I'm going to upload, I have 2 printers running at the same time. You can, when I have like they go from model to model on the print bed, you can hear this for a second, but honestly I was listening to it on the headphones and like, yeah, that's nice. Move 10 millimeters, 10 millimeters, 10 millimeters, and then 5. Okay, and then go all the way down. Okay, I'm liking this. Right, we can level the bed now. So leveling, go to this point. So this is way too... Oh, come on, how much I have to squeeze? Is my screw rotate? I think it's my screw that is rotating right now. That's why I'm not having it. Ah, okay. Oh God, I'm stupid. I can't believe I actually did this. I've not noticed there's something on my bed. There is something on my... What's the... What was lifting it? There's something lifting my bed. Huh? What's... something's going on with my bed. Let's investigate. Because this was lifted quite significantly. I have a Why do I have such a wobble now suddenly? Yeah, let's release the tension from the springs. Don't know what happened, but I had a massive gap in here, like it was warping for some reason. And I couldn't control it. Okay, that's fine. Alright, let's try now. Acceleration I haven't changed. I'm running on homing. I'm running 140, I believe. 140 on the homing. So that's, but because it's driving two axes at the same time, that's why you have a whine from the stepper. Menu, movement. Because I only have like homing and probing speeds increased. Now the bed is even, shouldn't have a problem. Because it was like literally, it was sticking out this much on this side. No wonder I had a problem. I think there was something in there. So, leveling. Yeah, now it's easy. Yeah, look at that. I can level it properly. But that was a problem. Okay. So what you want is a little bit of drag on it. Oh, this is... No, I still don't like this. I'm just gonna check my country because I don't trust it. Like my country isn't. Why do I have such a skew right now? I don't understand it. Like the springs are barely tensioned right now. There's not even that much squeeze on it. Glass doesn't seem to be. Looks okay. Okay, let's run the entire quadrant. Kind of gonna get it to more or less similar distance first. So it complains about the distance on here. Okay, that's fine. Let's go opposite corner. Maybe just needed a counterweight from the other side, opposite corner. That's all. Okay. Now front corner. Okay, and the opposite corner. So So I'm kind of at the end of the spring, so what I'm going to do, I'm going to add maybe 3 turns for each. And then repeat this process again. Okay, let's try this again. That should lower the entire bed a little bit, so I have more play up and down, because I was running out of space for this. That's why I prefer to have a level bed first before I do the axis. Okay, menu, movement, home, okay. Right. Hopefully that'll give me enough adjustments on both axes. Leveling, first point. Okay, second point. This is so tedious to do on a normal and yeah, now I have a actual space to move the bed up and down. And the last point, and I'm done. And then I just reheat the bed and retry this. Okay, now done. So now preheat for bed for PLA. Once it heats up, re-level the bed, and we are done, guys. We are happily done. That's it. No more. Then I can come back to editing. On bed, 34 degrees, nice and warm. So basically when you heat up the bed, you want to kind of stretch, because when the metal heats up it stretches, will release a bit of a tension. When you cool it down again, it might change the position. It's going to be very tiny changes, but again, very tiny changes are quite important. So yeah. 38 degrees. Start to feel it. And after that I'm gonna queue up a nice print. And I don't know, maybe I'll leave the live stream going if you want to watch how quietly it prints. In the background, in there you can see some of the stuff I printed for the portal turret I'm making. That's going to be fun. It's not my design, I'm just following someone else's design because I wanted to have a portal turret for some reason. But yeah, but it's so far so good. Okay, 52 degrees, so now it's hot. The middle is hot, this one is a little bit. Okay. Let's home it. And let's verify our... Now with all the imperfections right now, I could leave it as it is because I have a DoomedSardines, so DoomedSardines will fix whatever it's happened once you will heat up the bed. But if you don't have a DoomedSardines, you probably want to redo the bed leveling after heating up the bed. So let's do this. Leveling, first point. You shouldn't have to make big adjustments anymore. Yeah, it's a little bit lower than expected. Like this, I'm happy with this. Just a little bit of drag, nothing major. Yeah. Yeah, that's okay. And last. Okay, I'm happy. We can cool down stuff. Hot fun, cool down. And we can do a print. Okay. I can move my printer. If you want to have a look, I can show you my cool down printer. Can I move that much? I don't know how long is the cable right now. Ugh. Come on. So this is a water cooled one I have in here. See the cooling block in here. That's a custom cooling stuff. There's some old extruding bits that I need to clean up. But yeah, my second printer goes here, so it's a little bit tight, but so far it works alright. And this one is even more quieter than the other one because it doesn't have extruder for the fan extruder. But yeah, I'm enjoying it a lot. So that's the second printer. This one can go next to it now. We did stuff to it. Let's connect it. So they're homing right now. And when they're printing it literally like this, that's all you can hear. Which is quite nice. I'm enjoying that. Alright, that's all, I guess. I'm not going to leave this on for the cleanup. I'll clean it up and I have some videos to edit. So soon you're gonna have some more stuff to watch on my channel. I hope you're gonna enjoy that. Thanks for sticking around. Hopefully you learn a thing or two or useful tips on how to do maintenance for your 3D printer. And yeah, don't be me. Don't leave it for too long. Like I said, do it once every half a year and your printer is gonna be happy for a long, long time. I'll see you soon, guys. So